Hello, my name is James Carl, and this is my short summary presentation of the public lecture held by John DePillis on April 2nd. His presentation was all about physics and relativity through the uses of theorems and paradoxes. John DePillis is a professor of mathematics at the University of California in Riverside. He got his PhD in mathematics at the University of California in Berkeley and also has a degree in mechanical engineering from the Stevens Institute of Technology. Also, another credit to his name is his book called 777, Mathematical Conversation Starters. The theorem of special relativity has been a topic I have been interested in since elementary school, when I did a research paper on Albert Einstein. The basis of this theorem comes from Galileo, where he states that all things are different and distinct from each other, which leads to Newton's theory of time and space, then Maxwell's theory, and then to Einstein's theory, which is the theory of special relativity. This theory is where he accepted the physical theory between space and time. His theory states that there are two confirmed principles, that the laws of physics are always held valid in all identical systems, and that the speed of light will always remain the same for all observers despite the motion of the source. The main topics of conversation that Dr. DePillis discussed were that the perspectives of the world can and most likely are deceiving, such as how we perceive the world as flat. He also discussed the different theorems of perception as well as how relativity could be proved through the use of algebra and equation transformations. The last thing that he touched on was inertial reference frames. There were two very important theorems that Dr. DePillis discussed. They were called the bug and rivet paradox and the twin paradox. The bug and rivet paradox consisted of a bug and a rivet on the outside of an experiment, supposed to be going through the same reference frames, but to the people of the experiment, it did not appear that way. The other paradox is the twin paradox. Basically, this is where two twins are born to grow up to about 20 or so. One leaves the planet and goes on a space trip, traveling at the speed of which is a large fraction of the speed of light, then comes back later to find his twin brother has either aged far faster than he has or died. Both of these paradoxes conclude that even if two events seem simultaneous in one frame of reference and may be different from an observer's point of view that is moving at a relative speed to the speed of light. The next concept is the Slinky transmission. This video that I will be showing you displays what he is talking about. In a quick summary, we are looking at the movement of the top of the Slinky versus the movement of the bottom of the Slinky. Here's the video. As you can see, the top moves and the bottom does not. This is because, relatively, the bottom of the spring feels nothing until the top reaches it and there is no more force of the spring left against the gravity. The tension force represents the delay in the effect of the force on the gravity on the bottom of the spring in the terms of motion. The last example is the inertial reference frames. An inertial reference frame is a frame of reference that describes a time of place homogeneously, isotropically, and in a time-dependent way. These reference frames are fixed, identical at rest, perpendicular, and remain at zero when synchronized. This explains why no matter where you look, anything regarding Newton's second law, it all holds true. I personally was very interested in this public lecture because I wrote a research paper back in elementary school, back when I knew absolutely nothing about physics. And now that I'm old enough to understand them, and I can possibly even do them, makes it more fun to go back to. Thanks for your time.